Hello friends, this video on probability part 1 is brought to you by examfear.com. No more fear from exam. In this video we'll study probability. In probability we'll define probability. We'll learn what is sample space and sample outcome, events, types of events, algebra of events, mutually exclusive events and exhaustive events. Also we will learn axiomatic approach to probability. Definition of probability. Probability is the measure of uncertainty of various phenomena. Please note, the word uncertainty is very crucial. It's all about measuring the uncertainty. For example, when we say, will it rain today or not? Yes or no. So there is a 50% chance it will rain, it may not rain. Without looking at the weather. Then you say probability is 1 by 2. We'll discuss this more. Just understand, probability is nothing but the measure of uncertainty of various phenomena. To get the probability, we say number of favorable outcome by total number of outcome. For example, in this case, when I say it will rain or not, so there are two outcomes. It will rain, it will not rain. Total outcome is 1 plus 1, 2. And the favorable outcome is 1, it will rain. So it is 1 by 2. So it is number of favorable outcome by total number of outcomes. Favorable outcome is 1, it will rain. Total outcome is rain plus not rain, 2. Let me define various approach to probability. So there are three approaches to probability. One is the statistical approach, in which we observe and collect data. For example, we toss a coin. We toss a coin and we say it will be head or tail. So in this approach, what we do is we keep tossing coin. For example, we toss the coin 100 times. And 100 times we got 50 heads, 50 tails, let's suppose. Then we'll say probability of head is, again we'll use the same formula. Probability of head is 50 by 50 plus 50. This is the total event and this is probability of head. Similarly for tail also we'll do the same thing. In this approach what we do is we collect data, we observe and then we come to the conclusion on probability. The second approach is the classical approach, wherein only equal probable events are considered. When I say equal probable, that means the probability of occurrence of all the event is same. Example, when I toss a coin, the probability of head is 50%, the probability of tail is 60%. When I throw a dice, in that case probability of 1 is 1 by 6, probability of getting 2 is same, 3 is same, 4 is same, 5 is same, 6 is same. That means probability of occurrence of any event is all same. 1, 2, 3, 4, 5, 6 can happen with the same probability. This is what we call equal probable events. So in classical approach, we deal only with equal probable event. But in real life scenarios, we have cases where the events are not equal probable. For example, the coin is rigged. The coin is rigged such that for every time you toss the coin, the probability that you get head is higher and the tail is low, or a dice is rigged. For example, Sakuni Muhammad's dice is rigged die. So in that case, we can't use classical approach, and that comes the axiomatic approach. It's for real life events and it is closely related to set theory. And in this case, we can find out the probability for non-equal probable events also. For example, we have a scenario wherein a 2-person committee has to be formed from 3 men and 4 women. And we have to find the probability that there is no men in the committee. So in such scenarios, there is no equal probable thing. So in such cases, we use axiomatic approach. Let me reiterate once again because it's a very crucial thing. Probability is nothing but measure of uncertainty. For example, when we say it will rain or not, it's 50% because there are two possibilities: it will rain or it will not rain. So this is 1 by 2. The common formula of probability is number of favorable events by total number of events. There are three approaches. One is statistical approach, where we observe things, collect data and then come to conclusion. For example, tossing a coin, we tossed the coin 100 times, we got 50 head, 50 tail, and we then found that probability of head is 50 by 50 plus 50, because this is total event and this is favorable event. Favorable event in this case is head. Classical approach is also a good approach, a better approach, where we use mathematical calculations. But the disadvantage of this is that it uses only equal probable events. The third approach is the axiomatic approach, which is very good, and it can deal with any of the real life events. It closely relates to sets theory, wherein we create set of favorable events, and we create set of total events, and then we divide the numbers and we get the probability. That's what we do. We'll discuss this again. Now, before I go more into probability space, let me introduce two terms, sample space and sample outcome. So what is sample space? Sample space is set of all possible outcome of a random experiment. It is denoted by a symbol S, and sample point is each element of sample space. For example, when we toss a coin twice, right? So in the first thing we may get head or we may get tail. If we get head, we again toss the coin. So we may get head or we may get head or tail. In case we got tail, we toss the coin, we may get head or tail. So we got four possibilities. The sample space is all these elements. If we want to denote the sample space, we do it by comma separated. HH, comma HT, comma TH, comma TT. So this is sample space and it is denoted by S. When I talk about sample points, all these are sample points. So there are four sample points here. So HH is one sample point, HT is one sample point, TH is one sample point, and TT is one sample point. All these are sample points. So they are four sample points and one sample space. Right? Okay. Let's take some more examples to clear our concepts on sample space. A boy has 1 rupee coin, 1 2 rupee coin, and a 5 rupee coin in his pocket. He takes out two coins, one after another. So from this set, he takes out two coins, 1 and 2, one after another. Find the sample space. So let's assume he took out one first. Then he may take second coin as 2, right? Because one is already he has taken out, so he can't take out one again. Or he can take out 5 after one. Let's suppose in the first case he took out 1. Then in second he can take out 2 or 5. Let's suppose in the first case he took out 1. Then the remaining coin is 2 and 1. So he can take out either 2 or 1. So these are the sample space. These are the sample space for the given scenario. And sample points, you know, this is the sample point, this is a sample point. Every element is a sample point. Let's take one more example, it's a little tricky. So it says the person is noting down the number of accidents that happens during a year in a busy highway. So give me the sample space. So as we know that in a given year, 0 accident may happen, or 1 accident may happen, or 2 accident may happen, or infinite accident may happen. You never know, if tsunami comes, there may be infinite accidents. So the sample space for this is 0 to infinite, because it can be 0, it can be 1, it can be 2, it can be infinite. So that's the basic concept of sample space. Any possible outcome is sample space. For the number of accidents, there can be 0 number of accidents, or there can be infinite number of accidents. So the sample space is 0 to infinite. Let's take one more example of sample space. We are taking more examples because the whole probability chapter depends on sample space. A coin is tossed. If it shows head, then we draw a ball. And this draw ball is 3 blue and 4 white. There's a bag which contains 3 blue and 4 white balls. You draw a ball. If it contains tail, then we throw a dice. This is the scenario. The scenario is we toss a coin. There is a coin. If it is head, we draw a ball. If it is tail, we throw die. And die is 1 to 6. You know, we are asked to draw the sample space. Now first let's take a scenario wherein we got a head. So once you get a head, you are supposed to draw a ball, and all our three are distinct balls. With the next thing that comes out of a bag is, it can be a B1 ball, or after it can be a B2 ball, or it can be a B3 ball, 3 blue balls, or it can be a white 1 ball, or white 2 ball, or white 3 ball, or white 4 ball. So this can be a scenario when you have the coin toss was head and then you drew a ball. When it was tail and you threw a die, you can get 1, you can get 2, you can get 3, you can get 4, you can get 5, or you can get 6, because the die contains 1 to 6. So the total sample space is this, and sample points are definitely all these elements individually. So we'll find one more sample space. A coin is tossed repeatedly until a head comes. Find the sample space. That means if a head comes here, in the first go it stops. If a tail comes, this guy will again toss. If a head comes, stop. Again, if in the first go tail comes, in the second go tail comes, he'll keep on tossing until the head comes. In the first go head comes, tail comes, second go tail comes, third go tail comes, again he'll toss till he get heads. So that means sample space is something like this. You keep on tossing tail till you get head. So the last thing will be something like this, T, 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 T. This is infinite till you get ch. So the whole thing is called sample space. So we have seen sample space wherein the number of possible outcome. If you're talking about accidents in a road, it can be 0 to infinity. If you're talking about sample space for a die, it will be 1 to 6. If you are clubbing things, then it will be in the order in which you have clubbed. That's how sample space works. Thank you. Visit examfear.com to watch free educational videos, try free online test, get the best quality study material, study from the best tutor and mentors, and much more. Thanks once again.